This lesson is on data and statistics. So we're going to go over the different ways that we can display data and how we can use those displays to analyze the data. The first data display we're going to talk about are dot plots. And we use dot plots to display the frequency and distribution of the data. So basically how many times it appears a certain way, or how many times a certain data point appears, and the shape of the data. So looking at the first example of a dot plot, it says to create a dot plot to represent the data below, Savannah surveyed a random sample of 20 students from a local college to find the average number of hours of sleep they get each night. So the first thing I do creating this dot plot is I'm going to have to come up with a scale. And I can see that my smallest number is 4 and my largest number is 9. So I have to look at a scale that's going to let me get from 4 to 9. And on this particular one, I have just enough to start at 4 and end at 9. And what I'm going to do is I'm just going to make a dot for each data point. So I have a 6, a 7, 4, 8, another 6, 5, another 5, another 6, a 7, another 5, another 6, 4, that is not a lot of sleep, 5, 6, 9, 5, 8, 6, 6, and 7. So now we've created our dot plot and we can actually use this to find different things. So we can use it to find measures of central tendency. So that would be mean, median, and mode. We could also use it to tell where the data is skewed. So if I want to look at the skew of the data, I'm going to kind of trace along the top. And this data is right skewed. Now, it's the opposite of what you would think. The taller columns are on the left over here, but skewed actually is opposite of what you would think. So skewed pays attention to the tail of the data. So if the tail is longer on the right side, then it's right skewed. If it's longer on the left side, then it's left skewed. So this is right skewed data. And the survey was to tell the average number of sleep they get each night. So we're going to find the average. Now to find the average, you just add up all of the data points. So I'm actually going to open my data points back up where I crossed them off when I was making my plot. So for finding the average or the mean, you're going to add all the data points and then divide by the number of data points. So when I add all of these data points together, I get 121, and then I'm going to divide by the number of data points. And I was told in the problem that there are 20 data points. So I'm going to divide by 20. So the mean is 6.05 hours of sleep. We're also going to find the median. Sometimes median is a better measure of central tendency because average can be skewed by outliers. The median is not going to be affected by outliers. And remember, outliers are points that exist outside of the normal pattern. So that number 9 might be considered an outlier because there's only one person that gets 9 hours of sleep, and it's kind of far away from the mean. So for finding the median, we have to put the data points in order from least to greatest. So I'm going to use my dot plot. I have 4, 4, and then I have 5, 1, 2, 3, 4, 5 times. So 5, 5, 5, 5, 5. I have 6, 1, 2, 3, 4, 5, 6, 7 times. 7 3 times, 8 twice, and 9 once. And median is just the middle data point. So I'm going to scratch off 4 on this side and then 4 on this side. You can do that one at a time if you want. 4 on this side, or 3 on that side, 3 on that side. And you'll see I end up with 2 in the middle. If you end up with 2 in the middle, just add them together and divide by 2. So the median here is 6. And as you can see, that's kind of close to our mean, which means that our mean wasn't largely affected by any outliers. For example 2, I want you to go ahead and create your dot plot and find the mean and the median. Now we're going to talk about histograms. And histograms are used to show a set of data values that are closely grouped. With no outliers. And you can use the mean, because there are no outliers, you can use the mean to show the center of the data and the standard deviation. To show the spread of the data. Now looking at these types of data, this graph in the middle will be considered symmetric because it creates a normal bell curve. This data on the right is skewed because it's higher on one side than it is on the other. And like we talked about with our dot plots, the tail is on the right side, so this is skewed right. So wherever the lower end is the direction of the skew. And standard deviation just tells us how far the data points are from the mean. And what this does is it tells us whether or not the mean is a good evaluation or a good representation of the data. So if the standard deviation is high, that means that the points are very far away from the mean, which means that the mean might not be the best measure of the data. If the standard deviation is low, that means that all the points are close to the mean, which means that the mean is probably, or the average, is probably a good assessment or representation of the data. And we'll talk about finding standard deviation a little bit later on. In example 3, we're just going to simply create a histogram. So the frequency, or the number of times a data point appears, will go on the y-axis, and the time will go on the x-axis. The first thing I'm going to do is create a scale. The lowest time I have is 18 minutes. The highest time I have is 30 minutes. So I'm going to count by twos. And I know that this won't exactly cover my data points, but it will allow me to group them. So I have 5 data points that were between 18 and 20. I have between 20 and 22. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So these columns, this column right here, covers everything that happens between 20 and 22. Between 22 and 24, 1, 2, 3, 4, 5, 6, Looks like 6 data points. Then between 24 and 26, 1, 2, 3, 4, 5 data points. We'll start over with red. Between 26 and 28, I've got 1, 2, 3. Looks like just 3 data points. And then I just have this one left between 28 and 30. So I'm looking at my histogram now, and I can talk about the skew of the data, which again would be skewed right. For example number 4, what I want you to do is I want you to create your own histogram. I've gotten it started for you. I've decided on your scale, and then remember, everything that happens in this block right here, this block represents everything from 30 to 34. So you've got 3 data points that exist between 30 and 34. So your block will represent all 3 of those data points because of the scale. Now that you've created your own histogram and looked at the mean, I want to talk a little bit about finding a standard deviation. So first I'm going to tell you the steps for finding a standard deviation in the calculator. So to find the standard deviation in the calculator, the first thing you're going to do is go to Stat, Edit, and you're going to put all of your data points in L1. After you do that, you're going to go to Stat, Calculate, and you're going to choose one variable statistics, or one var stats. Then you're going to make sure to select L1 by pressing second 1, unless it already says L1. As long as it already says L1, you're fine. You're going to scroll down to Calculate, and hit Enter. And that's it for finding the standard deviation in terms of the calculations, but we need to talk about what your screen is going to show. So you'll see an X with a line over top of it. This is the mean. You'll see sigma X, which is the sum of the data points. You'll see the sum squared, and then you'll see SX, and then a little symbol that looks like this with X. So SX is the standard deviation for a sample. So this is the sample standard deviation. The next symbol is the population standard deviation. And what this means is that if you were using a sample of the population, so let's say I took 20 students out of the whole student body, that's a small group that represents the whole. So I'm going to use the sample standard deviation for that. Population standard deviation is when you're looking at an entire team. So you're looking at an entire cross-country team and averaging their times. You're looking at the whole population, the whole cross-country team. So you would use the population standard deviation for that. So what I want you to do is I want you to use this data set and try and calculate the standard deviation, and I want you to try and decide whether you think that we should use the sample or the population standard deviation. The next data display that we're going to talk about is a box plot. So we're going to use a box plot to show a set of data values that are spread out. And with a box plot, because those data points are spread out, the median is going to be the best measure or representation of the center of the data. And the interquartile range will show the spread of the data. So let's look at how we can interpret a box plot. So this first point is the minimum. The last point is the maximum. The first line or the second point is the first or lower quartile. The middle line is the median. The next line is the third or the upper quartile. The median is considered the second quartile. And what you'll do to find that is the lower quartile is just the median of the lower half. So after you find the median, you'll find the median of the lower half. The upper quartile is just the median of the upper half. Which is from the median to the maximum. Now to find that interquartile range, you're just going to do the third quartile, or Q3, minus Q1. And that will tell you the interquartile range. So looking at an example, we're going to create a box plot to represent the data below. The first thing I'm going to do is put my data in numerical order. Now that I've done that, I can look at both my minimum and my maximum. So my minimum is going to be 13. And my maximum is 55. Next, I'll need to find the median, and I'm going to do that by finding the middle data point. So if I group these, the middle actually exists right between 27 and 27. And I know that 27 plus 27 divided by 2 is just 27. So my median is going to be 27. Now that I've done that, in order to find the lower quartile and the upper quartile, I need to find the medians of these lower and upper halves of the data. So to find the median of the lower half of the data, it's going to be 23. And to find the median of the upper half of the data, I've got 30 and 34. So 30 plus 34 over 2, that's 64 over 2, which is 32. And now I can construct my graph. So the quartiles get a line. That's our box. And the whiskers extend out to the minimum and the maximum. Now to find my interquartile range, I'm going to take that upper quartile, which was 32, and subtract the lower quartile, which was 23. Which is 9. Now you can also find the minimum, the lower quartile, the median, the upper quartile, and the maximum by using that one variable statistics screen on your calculator and just scrolling down until you see min x, Q1, med, Q3, and max X, and that will tell you that information. The only thing it won't tell you is the interquartile range, which is just Q3 minus Q1. So for example 6, I'd like for you to create your own box plot to represent the data and fill in the minimum, the lower quartile, the median, the upper quartile, the maximum, and the interquartile range. And for example 7, I'd like for you to do the same thing that you did for example 6. Now we're going to talk about two-way frequency tables. So two-way frequency tables look at two different variables. So here it might be looking at color of shirt, right? So, and it's divided by girls and boys and the color of shirt that they're wearing. So the first variable will be whether it's a girl or a boy. The second will be what color shirt that they're wearing. Now a joint frequency is anything that's not a total, any frequency that's not a total. So that would be these frequencies right here inside that bold box. A marginal frequency is anything that's a total or anything that appears in the margins or outside edges of your chart. And we can use frequency tables to talk about percentages, about ratios, anything that would look at how many occurred out of a total number. So looking at example 8, it wants us to complete the two-way frequency table. And we know that the grand total has to be 100 classmates that were surveyed on their hair color and their eye color. So I know that this bottom, or the total, has to be 100 people. So if 12 of them were red-haired and 48 of them were brunette, then 40 of them have to be blonde. And in the other marginal frequency column, if 31 of them had hazel eyes and 28 of them had blue eyes, then 41 of them must have had brown eyes. Now I can use those marginal frequencies to fill in my joint frequencies. So the easiest column to start with is going to be the brunette column because I have 2 out of the 3 values. So the total brunettes has to be 48. So I used 48, 23 of them had brown eyes, 9 of them had blue eyes, which means that 16 of them are left to have hazel eyes. Now I'm going to look at the blue eye row because I also have 2 out of 3 values there. So there are 28 total people with blue eyes. 18 of them have blonde hair, 9 of them are brunettes. So that leaves 1 person that has red hair and blue eyes. Now I can look at the red hair column because I now have 2 out of 3 values. There are a total of 12 people with red hair. 1 of them has blue eyes, 5 of them have brown eyes, which means that there are 6 of them left to have hazel eyes. Now I can look at the hazel eye row. Because of that 6 that I put in, I now have 2 out of the 3 values. So 31 people have hazel eyes, 16 of them are brunette, 6 of them are redheads, so that leaves 9 of them to have blonde hair. And now the only joint frequency left to calculate is how many people have blonde hair but brown eyes. So there's a total of 40 people that have blonde hair. 18 of them have blue eyes. 9 of them have hazel eyes, which means that 13 of them are left with brown eyes. And now my frequency table is complete and I can start looking at other things. So if I wanted to look at the percent that have hazel eyes and brown hair or brunettes out of the whole population, I would look at the hazel brunettes box, which is 16 people, out of the whole population, which is 100 people. So 16 out of 100 is 0.16, which is 16%. Now I could also look at this and say, okay, what percent of the people with red hair have brown eyes? So there are 12 people with red hair, and 5 of them have brown eyes. So that calculates out to 42%. So that's how a two-way frequency table can be used to look at percents of the population. Now I want you to look at this table, and it's a little bit different. So we'll do this one together as well. So there are a total of 150 students. So I'm going to put that in my grand total box, okay? 40% said they have a cat. So that's 40% of the total do have a cat. Well, 40% of 150, or 150 times 0.4, is 60 people. So I know that 60 people have a cat. Now for no cat, I don't really have to multiply a percent. It would be 60%, right? But I know that that's going to have to be 90 people. Now we were given some other information to work with. Of the students that have a cat, 60% also have a dog. So we're looking at cat and dog. So there are 60 people that have a cat, and 60% of them also have a dog. So I can cross multiply, or I can say 60 people times 0.6, which is 36 people. So there are 36 people that have a cat and a dog. And because that has to total up to be 60 people, I know that there are 24 people who have a cat but no dog. Now the next bit of information we were given is of the students that do not have a cat, so this 90 people right here, 80% of them have a dog. So no cat, and they do have a dog, so 80% of them have a dog. So out of the 90 people, 80% of them have a dog, or 90 times 0.8. So 72 of them also, or have no cat but do have a dog, which means that there are 18 people left that don't have a cat or a dog. And to finish up the marginal frequencies, I'm just going to add these numbers. So 36 plus 72 is 108. 24 plus 18 is 42. And if I want to check my work, I can just add 108 plus 42 has to equal 150. So that's a way that we can use percents to fill in the two-way table. So that's all I have for you on the overview of data and statistics, but we will look a little bit more closely at box plots and two-way tables.